Imagine wearing a fortune on your finger. A platinum ring isn't just a stylish accessory. It's a piece of history, forged through a process that's as intense as it is fascinating. But have you ever stopped to think about the journey this precious metal takes to get there? From deep within the Earth's crust to the luxury jewelry stores, platinum's path is marked by extreme conditions and cutting-edge chemistry. Today, we're going to uncover the untold story behind one of the world's most coveted metals. It's a tale of rarity, of resilience, and of the heavy-duty processes that transform raw platinum into the sleek, sophisticated pieces we adore. So let's dive in and explore how platinum is made, from its rough beginnings to its glamorous finale. From the moment it's extracted from the earth to when it ultimately finds its way wrapped around your finger or nestled under the hood of your vehicle, we're about to take you on a fascinating journey on everyday things uncovered. Platinum is not just a rare metal, it's exceptionally scarce. To put its rarity into perspective, consider that every ounce of platinum ever mined throughout human history could comfortably fit within the confines of an average-sized living room. Unlike some other minerals that form in extensive veins, platinum is dispersed in minute quantities, often intricately intertwined with other elements such as nickel, copper, or iron. The primary sources of platinum are located in South Africa, Russia, and a handful of smaller mining operations in Canada and the United States. Notably, South Africa is the dominant player, accounting for approximately 70% of the world's platinum supply, which is predominantly sourced from the renowned Bushveld complex. Geologically speaking, this region is a veritable treasure trove of platinum. However, even in this platinum-rich region, extracting the metal from the rock is a far from straightforward process. One of the defining characteristics of platinum is its tendency to be accompanied by other elements. It's part of an exclusive group known as the Platinum Group Metals, PGMs, which also includes palladium, rhodium, ruthenium, iridium, and osmium. These elements exhibit similar chemical properties and are typically found commingled in ore, which means that when you mine for platinum, you're inevitably extracting these other metals as well. The platinum extraction process is akin to a complex and sophisticated treasure hunt, where mining operations meticulously locate and excavate platinum-rich ore deposits. Depending on the depth of the deposit, mining operations may employ either open pit or underground mining methods. For instance, in South Africa, where many platinum deposits are found, mines often extend far beneath the surface, with some reaching depths of over 1,000 meters. The ore is extracted through a process of blasting it from the rock walls, followed by transportation to the surface in massive quantities. However, the yield is remarkably low. For every ton of ore mined, a mere 3 to 7 grams of platinum are recovered, equivalent to the weight of a small coin. This translates to sifting through an enormous amount of rock to isolate a relatively tiny amount of precious metal. To begin the extraction process, the ore is first crushed into a fine powder to liberate the minerals. The resulting powder is then subjected to a process known as froth flotation, where it is mixed with water and chemicals in large tanks. Air bubbles are then blown through the mixture, causing the platinum-rich particles to attach to the bubbles and rise to the surface, forming a frothy layer that is skimmed off. Although this process may seem like a laboratory experiment, it is a crucial step in separating the valuable platinum from the surrounding rock. At this stage, the resulting concentrate still contains a mixture of platinum group metals, along with impurities such as sulfur and iron. To further refine the concentrate, it is smelted at extremely high temperatures exceeding 1,500 degrees Celsius, which is hot enough to melt rock. This process separates the metal-rich matte from the slag or waste material. The matte, which contains the precious metals, is then subjected to a series of complex chemical processes that can be likened to industrial alchemy. One of the most common refining methods employed is the aqua regia process, which involves dissolving the concentrate in a mixture of hydrochloric acid and nitric acid. This potent solution is one of the few substances capable of dissolving noble metals like platinum. Through a series of filtration and precipitation steps, the individual platinum group metals are separated from one another. Eventually, the platinum precipitates out of the solution in the form of a fine, grayish powder known as sponge platinum, which is essentially pure platinum in a raw, unrefined state. Once the sponge platinum is obtained, it is melted down in induction furnaces that reach temperatures of over 1,700 degrees Celsius. The resulting purified platinum is then cast into various forms, such as ingots, bars, or sheets, depending on its intended application. At this stage, the platinum begins to take on a more familiar appearance, marking the culmination of a complex and intricate extraction process. Jewelers, for instance, often start with platinum in its raw bar form, which they then skillfully roll out or cast into intricate shapes to create stunning pieces like rings, bracelets, and watches. However, the use of platinum in jewelry is just the tip of the iceberg. In reality, more platinum is used in the production of catalytic converters than in the creation of engagement rings. This is due to platinum's exceptional chemical properties, which make it an ideal catalyst, capable of accelerating chemical reactions without undergoing any changes itself. As a result, car manufacturers rely heavily on platinum in their catalytic converters, those compact metal boxes that play a crucial role in reducing harmful emissions in vehicle exhaust systems. Beyond its application in the automotive industry, platinum also plays a vital role in the medical world, particularly in the development of chemotherapy drugs like cisplatin. Its unique properties make it an essential component in the treatment of certain types of cancer. Additionally, platinum is used in a range of other fields, including electronics, fuel cells, and even in NASA's advanced space equipment. It's clear that this metal is incredibly versatile and has a wide range of applications. Given the complexity and difficulty involved in extracting and processing platinum, it's no surprise that it commands a high price. The process of mining, crushing, and refining platinum is labor-intensive and requires significant resources. However, the value of platinum extends beyond its rarity and the effort required to extract it. The metal itself possesses a unique combination of qualities that make it highly prized. It's remarkably stable and enduring, resistant to corrosion and tarnishing, and maintains its luster for decades without fading. Platinum is also denser than gold, giving it a substantial weight that's unmistakable when held in one's hand. These characteristics make platinum not only luxurious but also practical for use in a surprisingly wide range of industries. Moreover, platinum has become synonymous with prestige and exclusivity, symbolizing a level of high-end quality that's hard to match. While gold has long been associated with wealth, platinum has an aura of elite status, representing the next level up. This is reflected in terms like platinum credit card or platinum level service, which convey a sense of high-end quality and exclusivity. The association is not coincidental, as platinum's physical and chemical properties naturally lend themselves to this elite status. The next time you come across a platinum ring in a jewelry store or hear someone refer to platinum records, take a moment to appreciate the remarkable journey that this metal has undertaken. From its origins deep underground, where it's found alongside other elusive elements, to its transformation into a sleek and valuable material through the processes of smelting, purification, and shaping, platinum's story is one of remarkable transformation and endurance. It's a metal that's not just visually stunning, but also an industrial powerhouse, a medical ally, and a material that's played a crucial role in the advancement of space exploration, all rolled into one. If you have any questions or comments, please leave them below. Your input matters. Share your ideas for our next video in the comments, and we'll recognize your contribution. Thanks for joining us on this exploration of the fascinating stories of everyday things uncovered. Don't forget to like, subscribe, and stay tuned for more captivating content. Thanks for watching. And if you want to learn more, click the next video right here.